now. This is better. Okay, so I'm looking at team assignment 15 and 16, and we're going to start with question 1. So I'll read through it real quick. So if you have it pulled up, you can follow along. If not, then hopefully you can get the information from me just reading it and you'll remember from last week. So question 1 talks about children's movies. So it says it's commonly thought that children's movies show a lot of tobacco use. This is true, like at your age, you guys don't really think of it so much because you're probably not really watching children's movies often right now. But when you get a little bit older and you have kids of your own, then you'll notice, geez, a lot of the old children's movies actually do show a lot of tobacco use. It's kind of interesting. Not the newer ones. They're better about it now. Anyways, Hollywood executives want to convince moviegoers that in children's movies, the mean time showing tobacco use is less than 2 minutes. When I think about the context here, it says time 2 minutes. That's a meaningful number to me. I'm thinking this is numerical. And then it talks about mean time. Mean. It says it, mean right there. It's numerical. So that's like the first statement. And I can actually do the first 2 steps, population method from that. But then below I have the sample information. I'm actually going to take a look at that now because I think that helps us. So it says a random sample of 30 movies was taken and found that the mean time showing tobacco use is 1.5 minutes with a standard deviation of 0.5 minutes. Right there, I have mean time and I have standard deviation. This is definitely numerical. Let's look at the first thing I do before I even start. I just see what kind of data I have and what's going on here. So let's start with our population step. The first thing in my population step, I talk about the objects. So this is what's being studied. It's like the who, right? So it could be people, doesn't have to be people. So let's take a look at the sample again. It says a random sample of 30 movies. So my objects are the movies in this one. So here I always start with all because it's not about the sample, it's about the population. So it's all children's movies. See objects. The variable, this is what's changing between individual to individual. So this is what's changing from movie to movie in this case. So if we read through this, it says 30 movies was taken. We found the mean time showing tobacco use. So right there, it's the time showing tobacco use. So you can write the variable different ways. You can just write time and that works because that's what's changing. I'm going to be a little bit more specific in this one and say time showing tobacco use. I feel like it's just a little bit clearer when I go on to the next part of this first step. So time showing tobacco use, that's what's changing from movie to movie, right? So that's the variable. And then I just want to mention that this is numerical, right? We already mentioned that. We already talked about why we saw it's numerical. Time is a meaningful number. It talked about mean, standard deviation. Those are all my cues. The next part here is what we call the unknown. Now this is driven right from my variable. See how I wrote it's numerical. So my unknown is mu. And remember, you don't have to use the symbol. You can just type MU for mu. Don't use capital M because capital M stands for median. So my unknown is mu. Now I need to define mu. So I'm going to say mu is the population mean. I could always start it that way. Mu is the population mean. It has always started that way. And now I'm going to add the context of the problem. So what the problem's about. So what it's about and who, right? So the what is my variable, the who is my object. So for numerical, I always write it's the population mean and then the variable and then about the objects. So it's the mean time showing tobacco use, there's my variable, in my objects. So in children's movies. So I just kind of pull it out like that. I pull the variable and put it in here, and then I pull the objects and put it down here. So I put these two together for my unknown. I always do that no matter what, if it's numerical or if it's categorical, and we'll see at question 2 for the categorical problem. Then the last part here is my goal. I don't know how I want to write my goal because I know it's to support my HA. I just don't know what that is yet, so I'm going to wait. We just don't want to forget to go back. So I'm going to skip down to my method step, and then I'll go back to the goal. Remember my method step, I always have the same 4 parts: my null, my alternative, alpha, and what curve I'm on. We always have 4 parts in these steps. And I like them to be in the same order. So if we could write them always in the same order, right? Here, objects, variables, unknown, goal. It just makes it easy for me to read and check it out. You guys are doing null, alternative, alpha, the curve I'm on. So although I have my null on top, I don't actually write that one first. I write my HA first. So let's see what the problem says. It says that Hollywood executives want to convince moviegoers that the mean time showing tobacco use is less than 2. That's what we're trying to prove. So right here, that's my HA, less than 2. But I need to fill in what is less than 2, right? So it's my, right here, my unknown mu. So mu is less than 2. Then my null hypothesis is just the opposite. So mu is greater than or equal to 2. And of course, I can always write this as mu is equal to 2. I don't have to write both of these. I could just choose one. On a team assignment, if your team can't decide which one they want to use, of course, rate them both. But I may mention you only need one when I grade these things. So when you're doing your own work, just choose which one you're going to go with. It doesn't matter. The HA doesn't change. There's no option. It's the less than 2, because that's what we're trying to prove. This is, now we're going to look at the alpha. This is going to be the 5%, right? So if it's not given, I'm going to choose between 5% and 1%. I saved that 1% for the medical, life or death. So this is not medical or life or death, so I'm going to use the 0.05 here. And since it's numerical, right? We mentioned it's numerical up here. My curve I'm on is the T curve. And remember, the T curve changes shape based on degrees of freedom. So I like to mention degrees of freedom equal n minus 1, because this depends on this. So the shape of the curve depends on this. The shape is always normal, but what it looks like, right? How tall, how narrow, how much room's in the tail depends on n minus 1. Okay, now I'm gonna go back to my goal. I almost forgot. Remember, my goal is to find support. You could write it all different ways. You could say to find support, to show evidence to support, to find evidence to show, you know, you write all different ways, it's fine. But as long as it's about the HA. So I want to find evidence to support that the mean is less than 2. Well, I've already defined the mean right here in my unknown, so I could just copy and paste this down here. So I'm going to use that. I'm going to say to show support, to say that now I'm going to copy this right down. Population mean time showing tobacco use in children's movies. And now I'm going to add the less than 2. So I wrote everything I had right here, right, to find support that mu. Now I need to tack on the less than 2 is less than 2 minutes. I just want to write it out in words. Okay. So if you wrote this out in symbols, or if you just said mu is less than 2, or to find support of HA, it's true, but I want it written out in words. I might have said, write it out in words, not symbols, that kind of thing. That's the kind of grading I did for that question 1. Okay. Now we want to look at the last step, Well, I'm going to say the third step because it's not the last. It's just the third out of the 5. We only know this, the first 3 is my sample. Now it's numerical data. So for numerical data, I always have the same 4 things I need. So I need N, which is my sample size. I need X bar, which is my sample mean. S, my sample standard deviation. And I'm going to check to see if it's normal. Remember, I have different ways of going about this for numerical, so I'm not sure which way. I have to wait and look. So when I read my sample, it says a random sample of 30 movies, that's N, just fill it right in, was taken and found that the mean time showing tobacco use is 1.5. That's my X bar. So for the sample of 30, I found the mean time showing tobacco use is 1.5 with a standard deviation of 0.5. There it is. I just fill it in. You guys did a great job doing this. Finding that sample information. There were a few teams out of all of my classes that had a hard time checking, not hard time checking, but proving normal. So the first thing I always check is if N is greater than or equal to 30, because that's my easy way out. So is N greater than or equal to 30? Yes, it's 30. So I'm going to just put a check mark, yes, normal. And most of you guys did a great job with this. And you'll see on the team assignments, I wrote good. That just means all of this looks great and I'm happy with that. And I feel like really the same with this, the method step. Most of the teams did a really nice job doing this. Most of the mistakes were, it wasn't even really mistakes, it was things just being left out were in the population step. And you'll see that on your team assignment. I made a little note. This needs more, or this looks good, kind of thing. So that's my first 3 steps for that first problem on team assignment 15-16. So now I want to take a look at the second problem. This way we're looking at one numerical together and one categorical together, and then with your team you'll look at the other 2, which will be one numerical and one categorical. So question 2, I'm just going to kind of read the information and see what it's about. It says, potential side effect of the drug Lipitor's flu-like symptoms. So most doctors believe that this is very rare. The researcher hopes to show the medical community that over 1% of people who take the drug experience these flu-like symptoms. So right here it says 1%. When I see that 1%, I'm automatically thinking that this might be proportions because it has a percentage. So when I look down here at my sample piece of information, it says a random sample of 275 patients who take Lipitor was taken and found that 11 had the flu-like symptoms. So right there, it's part out of a whole, right? 11 out of all of the 275 have that symptom. So the question to these patients would be, do you experience these flu-like symptoms? And it's a yes or no. It's a category they fit into. So this is definitely categorical. So I was thinking that when I saw the 1%, and I'm kind of confirming it with what the other stuff I see. All right, so let's take a look at the population step. So the objects in this population step. So we could see a random sample of 275 patients who take Lipitor. So remember, I always start with all. Now you could say patients who take Lipitor or people who take Lipitor. I'm just going to say people. Doesn't matter. You can word it different ways. But as long as you get the point across it, it's all of the people that are taking the Lipitor drug. The variable, remember for categorical, I mentioned and I showed you in class that this is a little bit harder to write for categorical data. I normally just write the question. You don't have to write it as a question. You can write it as a statement. However you want to write it, but it's not as simple as numerical. Like numerical is just time, right? And the last one, you could just write time and that would be clear. This one's a little bit more to it. So this one's if they experience those flu-like symptoms or not. So I just write mine as a question and I say, do they experience the flu-like, oops, not an E, flu-like symptoms And I'm just going to say this is a yes or no question. And then from that, I say, okay, this is categorical. If I'm writing it on here, this is what I'm expecting for you guys to write on your paper, your work, okay, all of the time. So yes, I do want you to say it's categorical, or I want you to say that it's numerical, okay? Let me just write this out. It kind of bugs me when I make a mistake and I like it to look neat. There we go. Okay, so do they experience the flu-like symptoms? You could say, do they experience the side effects of flu-like symptoms? You can word it so many different ways. So I want everyone to word it the way it works for them. It's just, this is what's working for me. It's just like what's coming to my mind. My unknown. So if it's categorical, the unknown is P. And now I need to define P. So P is the population proportion. Now I need to say of what, right? So I could always start this statement out this way, but now I need to go into context, which is the objects and the variable. So for categorical, I actually say it's the population proportion of the objects and what they're experiencing. So I say this is P is the population proportion of people who take Lipitor, and I'm going to say and experience flu-like symptoms. Okay, so that's how I'm defining P. Even how I typed it up on my answer sheet is like different from how I'm writing it, because you could just write it a different way. It's just whatever you feel like writing. Like on my answer sheet, like I kind of wrote it more like side effects instead of flu-like symptoms. I'm just being more specific with the flu-like symptoms. I'm saying you can kind of write these things different ways. My goal, which I'm going to come back, right? I want to support my HA, but I need to come back to that. My method step is the next one. So my null, my alternative, alpha, and the curve I'm on. So I'm going to start with my alternative. So I'm going to read back. Researcher hopes to show the medical community that it's over 1%. So the medical community that's greater than 1%, I can write 1%, but I'm going to write it as a decimal, 0.01. You can write 1%, there's nothing wrong with that. But what is greater than 1%? It's not my HA, I'm making a statement of what my HA is. It's my unknown, which is P. P is greater than 0.01. My null is exactly opposite. P is less than or equal to 0.01. Of course, I can always write this as P equals 0.01. Okay. No need to write both, just choose one. My alpha, I didn't give you an alpha, so you're going to choose between 5% and 1%. I actually chose 1% because it's medical. Is it life or death? No. So your team may have said, actually, it's not life or death. I'm going to choose 5%. Either one works, right? So I will grade your work based on what you choose. Remember, I will always give you this on graded work. I will give you, like on an exam, I will give you alpha. I will say the level of significance is. And I might do that in a couple of team assignments so you can see what I mean. So you're not like just seeing it for the first time on an exam. We're studying proportions, P, so this is the Z curve. And remember, the Z curve does not change shape. It's the same shape all of the time. So I don't need to mention anything about N. I'm going to go back to my goal and write my goal based on my HA now. So my goal is to find support or to find evidence to support my HA. Okay, so to find evidence, so you'll see I write it different. So this is, I didn't write it this way on the first question. I wrote like to find support, doesn't matter. To find evidence, let's see. To say that, and now I'm going to fill in P, and then I'll add in the greater than 1%. To say that the population proportion of people who take Lipitor and experience flu-like symptoms, whoops, is greater than 1%. You're going to see I'm going to write that 1% this time. I don't always. I think I might, oh, I did write 1%. So we can write 0.01. It doesn't matter. Oops, not that one. This one, 1%. Or you can write it whichever way you want. So what I want you to know is when someone reads this, if there's someone that's not thinking like mathematically, to find evidence to say that the population proportion of people who take Lipitor and experience flu-like symptoms is greater than 1% makes more sense to someone just reading this in general than if it said is greater than 0.01, right? Does that make sense? It doesn't matter to me. Write whichever number you want there if you want to write decimal form or percentage form. I'm just saying if someone just randomly was to read this, like a sibling or a roommate, the 1% makes more sense when someone's just reading it and they're not thinking mathematically. Mathematically, the 0.01 is a little bit better because when we're working with percentages, we like to see them in decimal form. Okay. Anyways, let's move on to that sample step. So remember the sample step's like the easy one, something we're already used to. If we're studying categorical data proportions, this is where we need X, N, P hat, which is X divided by N, and I need to check for normality. I only check for normality one way, which is N times P naught times 1 minus P naught is greater than or equal to 10. So let's go ahead and read this sample and see what it says. A random sample of 75 patients who take Lipitor was taken. That's my N, so 275. And it found that 11 patients had these flu-like symptoms right here. Is X is 11. So I have 11 divided by 275, I get 4%, or 0.04 here. Now I need to check for normality. So here I have 275 times P naught. P naught is not P hat, right? P naught is from my null up here, which is 0.01. Let's make sure we plug in the correct value, which I think most of us did when I was kind of skimming through the problems. So that was nice. So plug this in. The question is this greater than or equal to 10? And it's not because it's like 2.73 or something. Greater than or equal to 10, I'm going to put a question mark. I'm going to say no. And I'm going to say this is not normal. Okay. So when we get to a problem like this and we cannot show it's normal, I'm going to end my problem here. That's it. I am not going to go further. I know we can't right now because we haven't learned anything further. But I'm saying in general in step 1, if you're not showing normality, we're going to end the problem right here. When we get into step 2, it's a little different. We actually continue with the problem anyways, and then we just say we don't trust our results. Our results could be off because we did not have a normal model.